Hey guys, welcome to the Junior Astrophysicist. This is Akash, and in this video we're going to be looking at scalars and vectors. Well, understanding physics, we should know a lot about the differentiation of quantities in it. So that's why we developed scalars and vectors. And in this video, we're going to be looking at some common scalars and vector quantities and also the definition along with the equation for weight. Let's begin. So, in physics, we can take two quantities, vectors and scalars. So firstly, let's look at what are scalars. So scalars are quantities with only magnitude. Magnitude is also referred to as size. But when you go more professionally, you say magnitude rather than size. So let's consider an example. If I say that a box has moved 3 centimeters, okay? The distance is 3 centimeters. Then this 3 centimeters is the size, and this becomes a scalar quantity, okay? So scalar quantities are quantities with only magnitude, okay? So that is a really simple definition for scalars. Now let's look at what are vectors. Vectors are similar quantities. They're really similar to scalars, but they have both magnitude and direction. Now let's consider an example for vectors. Let's say the same example. We're having a box which moves 3 centimeters. Okay. Now, if we have only 3 centimeters, then it's a scalar quantity because this is only magnitude. But if we say this box has moved 3 centimeters to the right, now it becomes a vector quantity since it has both magnitude and direction. So this is the simple way of understanding scalars and vectors. Now let's look at some simple quantities for scalars and vectors. Now the first scalar quantity is speed. Okay? Since speed doesn't really give you an idea of the direction, but only says like 3 kilometers per hour, stuff like that, okay? But a vector quantity for speed is called velocity, in which you say 3 kilometers per hour to the right, or 3 kilometers per hour to the left. So speed is a scalar quantity and velocity is a vector quantity. Next, distance. So distance is something like this 3 centimeter is what you call distance. Now in this case, it's just a scalar quantity. But when you give the direction of the distance, it is called displacement. So distance is a scalar quantity and displacement is a vector quantity. Next, we have mass. So what is mass? The amount of matter in a body. So mass is a scalar quantity because it doesn't really have any direction. But let's consider weight. Now, if this is a man standing on a surface, now the mass is just the mass within him and there's no direction, but the weight is the force caused by gravity. So weight is acting downwards since it's gravity. The simple expression for weight is equal to mg, in which m is the mass and g is the gravitational field strength. So W is equal to, if say his mass is around just 10 kg, we can say 10 kg times 9.81 newtons. Since the gravitational field strength is equal to 9.81 newtons, and you're going to have 98.1 Newton per kilogram as your unit of weight. Okay. So now, according to this, we can see the weight has a direction of down. So weight is considered to be a vector quantity. Now, these are the real simple ideas of scalars and vectors and the most simple quantities. There are more quantities, but those are a bit advanced. So this is it for now. Thank you. So I'm sure that by now you would have understood the definition of scalars and vectors, their differentiation, some common examples for scalars and vectors, and also the expression for weight, which is W is equal to mg, or weight is equal to mass times gravitational field strength. So if you liked the video, don't forget to drop a like, share, and hit the subscribe button so you can get more videos from the Junior Astrophysicist. Have fun learning. Bye guys. See ya.